When we talk about Hyster reaction, the core of the technology is advanced dynamic stability, or ADS. I want you to think of ADS as a governor for the truck, where every millisecond we're calculating the combined center of gravity of the truck and the load. We call that the stability triangle. And then based on many variables, we can put prohibitors on the truck if operator movements are deemed improper. However, if operator movements are deemed proper, then full truck functionality is given. We build onto ADS with detection packages, and there's two of them we're going to talk about today: object detection and proximity detection. Let's go take a look. So we'll start with object detection. This is a LiDAR scanner on the forks trailing side of the truck. It's seeing a 170-degree view, sees out about 25 feet. When an object becomes in a reasonable buffer distance in the path of travel of this truck, there will be a controlled decel. Now that reasonable buffer distance is between 1 meter and 2 meters. The reason for the controlled decel is to alert the operator with a change of speed that there's an object or facility infrastructure or anything in their path of travel in a reasonable buffer distance, and they need to look up, survey the situation, and either stop the truck or change their path of travel. If they elect to change their path of travel and go around the object, when that object is no longer in their path of travel, full truck functionality will be restored. So that's object detection, forks trailing side of the lift truck. Proximity detection is this ultra-wideband box you see up here, okay? Imagine a sphere around this lift truck now. Well, I have a pedestrian badge in my pocket. I have a sphere around me too if this badge is turned on. You could wear it on a lanyard, you could slip it in your vest pocket, but now I have a sphere around me too. If my sphere and this truck sphere begin to touch, this truck will have a controlled decel and my pedestrian badge will vibrate very rapidly until our spheres are no longer touching, okay? This is also the case with other lift trucks. If another lift truck in the facility has this ultra-wideband technology on it, it too has a sphere. When those spheres begin to collide and mingle with each other, then both trucks will have a controlled decel until they're no longer within proximity of one another. Once they aren't, full truck functionality is restored. So again, two detection systems we build onto advanced dynamic stability: object detection, forks trailing, backup sensor. Right? Agnostic, looking for any objects close to the truck in the path of travel. 360 degree with the ultra wideband, 360 degree looking for other lift trucks and pedestrians. So the last thing I'm going to show you is I'm going to get on this lift truck here and we're going to take a look at a couple things on the display. Earlier I mentioned prohibitors that can be put on the truck, right? Some examples could be changing my steer angle, and that gives me less max speed or less acceleration. Lifting my mast can give me less acceleration because I don't want to ever be in the case where I'm carrying a load, let's say above the overhead guard, and I'm going full speed. I could throw that load. Tilting forward may give me less hydraulic functionality than if I was at a 0 degree or negative back tilt. So let's get on the truck and I'll show you a couple of those things. So this is our interactive display screen, and first I'll walk you through a couple of things on here. So right here on the bottom you can see my max speed available on this lift truck is 5 miles an hour. Currently I'm going 0 miles per hour. You can also see things like your mast tilt, the weight on the forks, and the fork height. Now if any of these turn yellow, then that is just to alert the operator that, for example, with the mast tilt, I am slightly tilted forward. Now it would like me to be at a negative tilt, okay? So I'm at a negative tilt now. I have no weight on the forks, and I'll show you lifting the forks here in a second, how the gauge changes up there. But the first thing I want to show you is an example of a prohibitor, right? So I'm going to change my steer angle to where if I took off, I may begin to whip this truck or do a bit of a donut. As you can see, my max speed allowed went from 5 miles an hour to 4. That's an example of a prohibitor. I'm not going to get max speed out of this unit, and that's telling the operator that you probably shouldn't take off in that position, right? Or be doing donuts. I'll give you another example of a traction prohibitor. So I'm going to raise the mast a little bit, and you can see those numbers climbing. And as you can see, as I sit here in this position, I've only got my mast raised 78 inches, but you can see that I now have a max speed of below 3 miles per hour. So if I were to take off in this position, if I was loaded, it would probably be accentuated. I'd have less max speed, but I really don't have that much weight on the forks right now. But as you can see, I'm prohibited to 3 miles an hour. And again, this is to alert the operator. We don't want to be carrying loads, right, with the forks raised and above the overhead guard. So as soon as I begin to bring that down, I'm bringing my mast down, and I have full truck functionality again. Max speed is 5 miles an hour again. So an example of a prohibitor on the hydraulics on this truck would be, I'm going to raise the mast like I should in a 0 degree or negative back tilt, and I'm going to have full functionality out of the hydraulic systems on this truck. Then I'm going to tilt forward and show you that I have reduced functionality because, again, that's another alert to the operator that we never want to be raising and lowering loads in a tilted forward position. So I've got full functionality out of this truck. As I begin to lower it down, I have full functionality. And now I'll begin to tilt forward. And what we're going to see here is when I begin to raise again, a slightly reduced speed in our hydraulics because we don't want to raise and lower our loads in that position. Now, if this truck was loaded, if this truck was fully loaded to the rated capacity, that hydraulic prohibitor would be much more accentuated. So in closing, Hyster reaction. Advanced dynamic stability, always calculating the combined center of gravity of the truck and the load, and has the ability to put certain prohibitors on the truck if operator movements are deemed improper. We paired detection systems on top of advanced dynamic stability, object detection and proximity detection, to look for objects, pedestrians, and other lift trucks in the environment. Thank you so much for taking the time to watch our video. We can't wait to hear from you.